Okay, perfect. So good afternoon to everyone. I'm Nicola from River Cleaning, and as Cledisa was mentioning before, we're going to install the river cleaning system in Albania. So that my goal for this brief presentation is to make you understand a little bit not only what are the features of the river cleaning system, but also what paths you can adopt, what ways you can adopt if you want to replicate and use one for your own use cases, and how to understand if this is something that would serve your cause in trying to reduce plastic pollution. So very briefly, what is the river cleaning system? We didn't invent anything new, actually, because the river cleaning is a barrier. And barriers we know that have been used for a very long time now. But what we tried to do was to rethink the concept of a barrier and make it a little different from what it was before. So we like to think that in our stories, barriers are not passive and low technology things that will simply float on water, but they can be long-term, sustainable, smart, and strategic devices that will ultimately be used as a tool for the well-being of the entire river basin management system. How would we do that? Well, basically, the river cleaning system are made by are a modular system, and they're made by these floating modules, which are the round things you can see in the pictures on the right. These floating modules are, as the word says, are floating on top of the water, so they can adapt to the increasing or decreasing of the water level. And they are spinning on themselves. They're spinning on themselves by virtue of the river flow itself. So, how do they spin? They're basically, the entire technology is basically either entirely passive or self-powered. Passive means that there is no energy whatsoever involved, while self-powered, of course, means that we're using energy, but we're producing the exact amount of energy that we use. And the third point, main point, is that these systems are versatile, and we also have experienced in design-based approaches. So it means we will not propose anything which is standard to you, but we will most likely study what your place look like, what the environmental needs, what the accessibility needs are of your of the place you might consider for an installation, and we're going to build the system. We're going to tailor-made that for you. This is the approach we also had with the Riverlana system for Tirana. What challenges do we aim to solve? Well, we basically all know about plastic pollution, so that is something which I think it's already in the back of the minds of the people. We know that, for example, 1.8 million tons are coming from rivers. There's also quite a lot of literature, scientific literature lately, that is also upgrading our knowledge about what's actually coming down from the rivers and going into the sea in terms of plastic pollutions. But you may not know that rivers are substantially plastic reservoirs. What does that mean? It means that most of the litter that gets discharged in a certain point, let's say in a river basin served area, mostly 80% of this of the whole amount of this litter spends months, if not years, actually trapped in river basins. It means that litter is actually moving very slowly between like creeks, tributaries, minor waterways, and finding their ways into the biggest streams, and then ultimately getting discharged to the sea, if that happens in any way. And this means that across the whole river basin, businesses and people are equally affected. So the impacts of plastic pollutions are not only environmental, but also social and economic. So I mentioned before that barriers have already been existing, let's say, for a long time in history. But what makes you want to install river cleaning instead of something else? We tested the technology with the University of Palermo, which is located in Sicily. And those tests highlighted 97.4 average macroliter retention. We're talking about the surface liter, but also the semi-submerged liter, because the system itself extends partially down the water column. So it's not only what floats on top of the river, but actually most of the litter is distributed like just below the water level. Very important feature of river cleaning is that it does not require additional energy. So unlike, for example, some other technological systems that require, for example, a power supply from external sources, we do not. So even in systems that are completely automated, the energy is produced by the system itself. So there are no hidden costs. If you want to install one of that, you do not have to spend, let's say, a lot of money for energy supply. And that is, I think it may be a good point for example, municipalities. On the other side, we also have low impact on the river hydrology. It means that it's not a fixed barrier, so it's not like a sort of wall stopping the flow of the water. But since it's made of these modules that spin and let water pass through the barrier, the barrier stops the litter, but it doesn't stop the water flow. So everything is still free to flow according to the laws of nature and the laws of the river. And last but not least features is that the system is active 24/7, so it's autonomous. You do not need to have like an operator stay on site and do the work of removing the litter, but the barrier displaces the litter for you. So basically, you don't have to work. The barrier does the work for you 24/7. And it can be remotely controlled. Now, the Albanian system specifically does not have this feature because it's operated manually. But if you would want to install one of the systems, what are we going to propose to you will be most likely remotely controlled and fully automated. So technical features, I'll go just for the main ones to avoid annoying you. So this modular structure, as you can see from the pictures, by the way, that is the system that is going to River Lana. These floating modules, they behave like a chain of gears. So basically, the litter gets stopped, and at the same time, it's also being transported from one of these floating modules to the other in line, and the next one, and the next one, and the next one, until they get to the collection point. So from that single collection cage, you can pick the litter up. So no clogs in the middle of the river, no people needed to go there and simply remove the litter with cranes or something like that. It's the litter collection is very easy. Second is the structure of the barrier is made to be lifted or opened. It means that we can, if there's safety concerns, like for example, flooding periods, we can simply lift it up and make sure it's out of the way. Because one of the things we say most of the times is that sometimes river cleanup operations fail because these structures are not, of course, when you have a big flood, for example, and the river flow is quite dangerous, there is no system that can actually withstand the power of the river. So if we do not have solutions that are able to be safe in those times, most likely the intervention will fail, and we would have just like trashed away our money. Boats can pass because the technology can be opened or lifted. And finally, all the automation in the barrier means the lifting systems, the sensors, is self-powered, and that means you can control it and check whether it's functioning properly anytime from remote, so like from an app. Going to conclude in a couple slides. So if you're a potential user, which kind of user could you be to install these technologies? Currently, we have these targets you see listed below. So the B2G market, mainly municipalities that may want to deploy one of these systems to recover the litter they have in maybe rivers flowing through urban areas. Then there's the B2B market. So most likely, most of the requests we have collected come from environmental services companies, and this has been the case for Southeast Asia, South Africa, and the USA. There's also particular applications that can be done in hydroelectric power plants, and that has been the case for France and Italy, because as you know, hydroelectric power plants also tend to accumulate litter and other kind of waste before their turbines. So they do not want this material to get inside the plants because they have to stop production. And finally, we also worked with some NGOs in Turkey and Greece. We're setting up some projects. Finally, what do we usually do to put this technology to action? First, we identify the need. It could be a request on our website. It could be someone we approach. But first, it's always we try to understand the market specific or the user specific needs of our contact. Then we look for a partner in the specific market or in the specific place. So the aim is to build a pilot in that market. Third is we build the ecosystem, because there's many there's many people that needs to be engaged and involved when we plan these installations, like the municipality, the water agency, etc. A lot of people needs to be onboarded and need to know about it, and sometimes give permissions. And finally, we define the metrics for success. So we start from understanding what would you consider a successful pilot or a successful project in your area. And of course, once we define the metrics, we keep track of them, because we're happy if you as a user are happy. And that's it basically. So don't be the bad guys, be the good guy and clean that river. And if you do have a request for us, you can feel free to reach out at info@riverclean.com. There was supposed to be LinkedIn and Instagram icons, but they disappeared for some reasons. So the first one is the tag name. You can find us on LinkedIn, and the second is for Instagram.
You can share it on the chat as well. So
I can share it on the chat, yes.
Yeah, great. So thank you very much.